Assalamualaikum warahmatullahi wabarakatuh. First of all, I want to thank the organizer of I-Semantic for giving me the opportunity to present my research. Before I start my presentation, I will introduce myself. My name is Dwi Intan Af'idah and I come from Diponegoro University. The title of my research is Long Short-Term Memory Convolutional Neural Network for Indonesian Sentiment Analysis Toward Touristic Destination Review. Introduction. Large amount of the text has been created on the internet which require assessment to convert this data into useful information. And as we know, sentiment analysis is still hot issue for the data processing. Sentiment analysis is used to evaluate an entity in textual form by representing emotion or sentiment which are present in the text. The primary task of sentiment analysis is to conduct sentiment classification to determine polarity. As we know, deep learning have better performance for sentiment analysis than classical machine learning. LSTM and CNN are the popular model of deep learning. However, LSTM and CNN still have weakness. But it is turned out because combination of LSTM and CNN have shown excellent performance for sentiment analysis in English corpus. And the problem is limited research on LSTM CNN for Indonesian sentiment analysis. Then the other problem is pre-training model selection because pre-training is needed for word representation to be more accurate. Next, word-to-fact was chosen as the pre-training model because word-to-fact can capture the semantic meaning of text. Therefore, we combine LSTM and word-to-fact to be one of solution. The other problem is government need material of consideration in development of Bali's tourism, since it contributes to foreign exchange. So we propose the research about long short-term memory convolutional neural network from Indonesian sentiment analysis toward touristic destination review. Research method of LSTM-CNN. Before classification process, pre-processing text and pre-training word-to-fact have been done. Classification is beginning from each word from text review that has been pre-processing will be entered in word-to-fact layer to match the vocabulary with the vector. And words that have been turned into vector will be input in LSTM layer. After LSTM process is done, result of LSTM will enter in CNN process that beginning from convolutional layer, pooling layer, fully connected layer, and the last is output layer. Research framework. This research used data from tripadvisor.com gathered using a crawler based on Selenium Python. The gathered data are then noted manually into positive and negative label. The dataset comprises 10,000 reviews, of which 5,000 each are positive or negative. The process of data is touristic destination review as input, then data labeling. After that, pre-processing text, and then word embedding use word-to-fact pre-training. The next process is data allocation into trained data and test data. Trained data will be processed by LSTM-CNN training. Then test data will be used to test and evaluate LSTM-CNN performance. Finally, the result of process is finding the best solution. Next page about scenario of experiment. There are 7 parameters used in study and number of combination is 288. The first scenario analyzes the effect of word-to-fact parameter on accuracy, and the second scenario analyzes the effect of LSTM-CNN parameter on accuracy. The seven parameter are architecture of word-to-fact, evaluation of word-to-fact, dimension of word-to-fact, pooling layer, dropout, learning rate, and convolutional activation type. Experiment result. From 288 combination of experiment, the highest accuracy is 97.17%. Next, result and analyze about the effect of the word-to-fact parameter combination is shown by diagram. First, the skipgram word-to-fact architecture rendered higher accuracy compared to CBOW. Second, hierarchical softmax delivered higher precision compared to negative sampling. Third, as depicted in figure, the word-to-fact model with a dimension of 300 provide the best result. Next, result and analyze the effect of LSTM-CNN parameter combination is shown by diagram. First, average pooling rendered greater precision compared to max pooling. Second, deploying dropout 0.7 presented the best accuracy sampling. And third, learning rate with value 0.0001 delivered greater precision compared to learning rate with value 0.001. And the last, when compared to tongue function, higher accuracy is obtained when the convolutional activation is performed using ReLU. Result. First, the experiment result indicates which the best LSTM-CNN and word-to-fact model are. The accuracy of the best model is 97.17%. The LSTM-CNN parameter are average pooling, dropout value of 0.7, learning rate at 0.0001, and ReLU function being used for convolutional activation. Third, the word-to-fact parameter which used in the best model are skipgram architecture, hierarchical softmax for evaluation method, and dimension of 300. The last, on the basis of this best parameter, we compared it with another model. We made a comparison of LSTM-CNN and LSTM as depicted below. The accuracy of LSTM-CNN is 97.17% and the accuracy of LSTM is 90.82%. Next, conclusion. The best classification accuracy for the LSTM-CNN model is attained using average pooling, a dropout of 0.7, learning rate of 0.0001, and ReLU function being used for convolutional activation. The next conclusion is word-to-fact is most accurate when using the skipgram architecture, which a hierarchical softmax evaluation for n 300 dimension. And third conclusion, the best parameter of LSTM-CNN and word-to-fact model delivered a precision value of 97.17%. So, we propose the sentiment analysis performed on Indonesian language based review pre-training to touristic destination be performed using LSTM and word-to-fact model. That is all from me. I would like to thank you for your time and attention. Wassalamualaikum warahmatullahi wabarakatuh.